Hello. The DeskProto software supports rotary machining, so use your fourth axis on your machine to slowly rotate the part while machining so the cutter can reach all sides of the part. And DeskProto supports that even a bit better than most other CAM programs, as for some geometries like a curved table leg like this one, the cutter needs to travel below the rotation axis line, as you can see there. Well, DeskProto allows that. Most CAM programs support rotary axis machining by using a flat relief and wrapping that around a cylinder. And with that algorithm, it's not possible to travel below the rotation axis like needed for this geometry. Well, we already created a tutorial video about that subject. However, that was 6 years ago for DeskProto version 7.0, and since then the software has been improved a lot. User interface has changed. We now have DeskProto version 8, and so it's time for a new tutorial video. And in this video I will use a geometry that I downloaded from cncdesignhub.com. You can see it. Here is the website, cncdesignhub.com, and on that website I'll search lion table leg. Oh, there it is already. I can click on it. And here we see the geometry that I have downloaded and want to use for this tutorial. Here it is, download. This is the STL file which I have saved on my desktop, so I can immediately proceed and start DeskProto. Obviously we need to start here the multi-axis edition. I want to start a new geometry project, and as said, the STL file is on my desktop. Here it is. Yes, and this is the geometry that we want to machine. Was a bit too quick. So, and the first thing that I want to change is the machine, because I want to do this on a SainSmart machine. Where are we? As here, SainSmart 4040 Pro. Yes, the speed and units will be reset. That's okay. And next I can go to the part parameters to define what exactly we want to machine. Double click, and obviously I need to use a rotation axis that will automatically make some settings, which I now will ignore. When I say apply, you will see that this is not what we need, so we need to rotate a 90 degree around the z-axis to get it aligned. 90, and again apply. That's better. Still not what we want. I also need to center the geometry. Apply, here we are, that's better. So this is what we want to machine. However, not quite. The leg is a bit thin and I fear that it will easily break. So the length is okay, and I want to make it a bit thicker. And my block is 26 millimeters in both in the thickness and height. So when I set that to dimensions, not uniform, I can make 25x and z both 25 millimeters, and you will see when I apply it will be a bit thicker. The length is okay, as said, so that's fine. And my material block is a bit larger. It's 26 millimeters in these dimensions, and 80 for the x, 80 to 6, and again 2, 6. Yes, apply. So the block is a bit larger. And then the last thing for the part parameters are the support bridges, support tabs. The two default tabs would look like this. However, I want to make them a bit thicker, and so I set them to custom set. I want to change this support, so I need to first go to the select tool, and then you see the color. Now I can select this support tab. when I look at it from the side, from the left, I can make it larger. I can do that either by, this is the move of the resize tool. I can do it using the mouse, but I want to make it 10 millimeters, a cylinder of 10 millimeters. What you see is only the bounding box. So this is easier for me from -5 to 5. And here it should not be aligned by the zeros. I want to make that from -9 to 1 millimeter. So here's a cylinder of 10 millimeters diameter, and the rotation axis is nicely inside the cylinder, which is important for me. Okay, that's this tab. When I say apply, you will see that it changes. And the other support tab, I also want to make it a bit larger. So again, select tool, this tab. Now view it from the right, and I want to make that 8 millimeters. 4, and again 4. And what did I do for the other one? Let me check my yes, it was from -5 to 3, also not completely centered. Okay, again apply. Here's the other support tab. So this is exactly the geometry that I want to machine. Okay. And I want to do that using 2 operations, roughing and finishing. So the first operation I will call, of course, roughing. R-O-O-I-N-G, roughing, yes. I want to do that with a bullnose cutter, 6 millimeter. That's okay. Feed rate. I want to be a bit careful, as I do not know which torque my rotation axis can handle, so I put that on 600 millimeters per minute. Spindle speed is okay, though on this machine the spindle speed will be set manually, so what I enter here in fact doesn't matter. A long X, that's okay. Roughing a skin of half a millimeter, ramping. And for the layers, I want to go down in roughing layers of 8 millimeters each, as the cutting forces for this very small object need to remain a bit low. So on the area, I'll come back on that later. I'll just say okay for, oh no, I need to go back to general to set the distance between the toolpath. I can do that only after I set my roughing skin. So toolpath distance 1.5 millimeter, and for this one 0.4, that's fine. So this is the roughing operation. I can calculate toolpath for that operation, and you will see in a minute that the cutter goes down in layers of 8 millimeters. So here's the first layer, here's the second layer. That can disappear. And then I want to create a second operation and make that finishing. So I say add operation, here we are. Double click to open the parameters. Finishing, yes. I want to do that with a tapered cutter, and I bought this one from CMT, which is a nice cutter. I want to do that very accurately. So 1/10 of a millimeter, both settings. 1000 millimeter per minute is okay for the finishing. As said, this one doesn't really matter. No roughing, area will come later. So let's just calculate toolpath and see what happens. Oh no, I forgot one detail. For the finishing, I want to use the toolpath around A reverse. I want to start on this side and then move towards the place where the actual rotation axis is, so where the movement comes from. I want to use the helix, however that's disabled, and I know why, because on the movement tab I've selected meander, and meandering and helix doesn't go together, so I need to select conventional, and now I can select the helix operation say OK, and again say calculate toolpath. Okay, ready. Here are the toolpaths. Let me make roughing invisible and then zoom in a bit. And it seems that the toolpaths are not correct here. So let me first calculate a bit rougher toolpath on only a small section of the leg in order to show you what exactly happens here. And here we are, the toolpath only for a small area. Now you can see what happens. The cutter goes up, goes down, and this part of the surface, this surface is simply not machined, so material will remain over there. Why is that? That is because, and let me show you a front view, that part of that surface is below the rotation axis. Here's the rotation axis, and though DeskProto can machine below the rotation axis, by default that had been switched off in the area to be machined. So again, to go to the area, it just was on use material block above rotation axis. Well, we just changed the X, so it's now on custom. But you can see here the radius of the cylinder shape area to be machined ends at Z is 0, ends at 0. So when I want to go deeper, let me cancel again, go to the front view and say here on the left right bottom screen you can see the Z value. When I go to -10 here, all will be okay. So I go again to the area to be machined area, and instead of R0 I say R -10, and let's see what happens now. Again, a bit of a calculation. Here we are, and you can immediately see why we do not use this as a default setting. It says these strange toolpaths will confuse novice users who do not understand what is happening. These butterfly wings toolpath, why are they here? Well, I've created an even more simple and even simpler DeskProto model in order to explain exactly to you what happens here and why these toolpaths are present. Let me switch to that DeskProto project. As you can see, it's a very simple project, just a plain cylinder. However, it's located outside the rotation axis. In this orientation, the complete geometry is below the rotation axis. So let's see what happens when I calculate toolpath. Here the situation where the cutter cannot go below the rotation axis. So these toolpaths we will see when we calculate the simulation. Geometry operation, calculate. Here you can see that some extra material will remain there unmachined, which is not the model that we wanted to create. And we can change that, as just explained, by changing the area to be machined. Here we are, and instead of a minimum radius of 0, we enter one of -10 millimeters in this case as well. Okay, simulation will be reset, that's okay. New calculation. Now we see these strange butterfly wings, and when we now again calculate the simulation, calculate, we'll see that now the result is correct. So now to show you in more detail what happens with these toolpaths, I will now make a side view. Here we are, and then the nice thing is that I now can use DeskProto version 8.1, so you have a preview. As in the animation, a new option has been added. Not only show the true cutter, also show the true orientation. And now the cutter will remain vertical and the geometry and the part will rotate in the simulation. So that's a nice extra option. Let me switch on the geometry to clearly show what happens. Here it is. Speed a bit lower to see what happens, and now when we start the animation we'll see that the cutter goes down until it touches the material, and then the block starts to rotate, and now the cutter goes down to ambient level, to Z minus 10. Now again it touches the geometry and it can machine the complete geometry from the other side until again it goes down to minus 10 and starts the next butterfly toolpath. And when we go now, yes, it's the well, I can stop it now because you've seen the complete toolpath. The other three will repeat the same toolpath. So what I will do is I will run the animation again and now see what happens when the cutter is located a bit too far to the right, for instance. Then let me stop here a bit. The part will be a bit too large, and then when we continue the toolpath until the cutter again reaches the same area on the surface, which is almost there, and we are there. Yes, now well, the part will be a bit too thin instead of too thick. So as a result, a ridge will be present on the surface, which is clearly visible in the resulting part. So far the explanation of the butterfly wings and why the 0 point for rotary machining needs to be very accurate. Now I can finish the project. So restore the area settings of the finishing operation X should be from 0 to 80. Yes, it will automatically start calculating. Here we are with these enormous butterfly wing toolpath. Now I also need to make the same change for the roughing operation. Change the area. Instead of use material block above rotation axis, I say custom, and here as well to a depth of minus 10 millimeters. Okay, calculate these toolpaths as well. That's a bit faster than the finishing operation. And finally I can make a simulation of the resulting part. First roughing, calculate. Here we are, a rough model obviously, and then finishing, which will take a bit longer I assume. So a nice simulation, and again set to rotate. Here we are, this is what we want to machine. Okay, hide the simulation, and now I can save the NC file, first only for the roughing. Save and see only the visible operation, lion rough. Yes, it's on the desktop, that's okay. Here it is, and the second one, cancel. First make the other operation visible, and then again say save, and of course that will be lion. Finish, save, and with these two files I can now proceed to the milling machine. For this project we use the SainSmart rotation axis, which we installed on our 4040 Pro machine. This complete process of installing, aligning, configuring, etc. for the rotation axis, we captured that in a separate tutorial video, which you can see here. So when rotation axis machining is new for you, we strongly advise to view this video before you start with your own project. Okay, for the current video, we can now proceed to the milling machine. And you now see the block that we have set up has already been machined. We machined the cylinder shape to check if the 0 point had been correctly set, see the video that I just mentioned. And here's the resulting part, very small, finished with one continuous helix operation, rotating in the same direction all the time from a 0 degrees to over 300,000 degrees, more than 800 rotations. The part is a bit small to clearly show it to you sitting on my desk, so we made a separate, we use this small, a rotation table to make a close-up video, which you see here. I am very happy with the result, and I hope that the video will help you achieve similar results. For now, thank you for watching.